7.6 is all about non-right triangles. It's a bit short, so I'm also going to use one example to help the understanding. So, getting right into it, what is non-right triangle? So, non-right triangle is basically saying that it's non-right. It doesn't have an angle of 90 degrees. So, even if a triangle isn't a right triangle, you can make it into two right triangles by drawing a perpendicular line from angle A to side A. Basically saying from here to here by drawing this perpendicular line called H. So now we're going to see how we can use this or when we use this. So we're going to use this with the Pythagorean Theorem. So if we take a look at this blue triangle here, we're going to use the original Pythagorean Theorem and just see where it goes from there. So let's use a different color. A minus x squared, as you can see, I'm going to read this part, plus h squared is going to be c squared. This is what we learned in junior high, so it's not going to be that hard. But now I'm going to expand this part here to a squared minus 2ax plus x squared plus h squared equals c squared. Now if we take a look at this part here, and then take a look at this red triangle, we're going to see something odd. X squared plus h squared. Again, when we use the Pythagorean theorem, this is going to equal to b squared, right? So we're going to simplify this, and instead of using x squared plus h squared, we're going to try using b squared. And that leads us to a squared plus b squared minus 2ax equals c squared. And again, if we simplify this is eventually a squared plus b squared minus 2ab cosine c equals c squared. And this is basically the law of cosines. So if we see a non-right triangle and we have three sides that we know and one angle, then we're going to use the law. Then we're going to use the law of cosines. When we only know two sides, I think I made a mistake. I'm sorry. Okay, so not when we know three sides and one angle. We're going to use the law of cosines when we know. Actually, I was right. Yeah, when we know three sides, not three sides and one angle, but when we know three sides, then we're going to find an angle, or whether we know two sides and one angle. This is going to be when we use the law of cosines, like this. Okay, so now looking at an example. For just simplification or clarification, we're going to put x as c, 5 as a, and 3 as b. And I haven't mentioned this before, but cosine c or cosine a, cosine b, these angles are all going to be the angles opposite from the side. So we put x equals c, so cosine c, angle c is basically going to be 70 degrees since it is opposite from side x. Okay, so now how do we find x? Well, we're going to just substitute these values into this equation here, the law of cosines. X squared is going to equal to 5 squared plus 3 squared minus 2 times 5 times 3 cosine and 70 degrees. So if we do this, this is around 23.7. So basically, x is going to be around 4.9. And that is how you use this equation and find either an angle or a side. Okay, since we took a look at law of cosines, we're also going to take a look at law of sines. But before I get into it, I'm going to use this textbook here to explain the law of sines. Okay, now moving on, the law of sines. If we explain the law of sines, we're going to try to remember this equation. This is going to be a lot easier to remember than the law of cosine. It's just sine A over A, sine B over B, sine C over C. Basically the same thing over the side. Sine of the angle over the side. Okay. If we see this part here, it may be a bit more helpful to understand, but the picture or the triangle explained is kind of the same thing as the law of cosine, so I'm just going to try to get right into an example. Okay, so if we take a look at this example here, it wants us to find the length of the cable from T to A, which is side C. And we see 3 angles and 1 side. So we know that we have to use the law of sines in order to solve this problem, because we can only use the law of cosines when we know 3 sides or 2 sides and 1 angle. So since we know that, we're going to use this equation here, the law of sines, in order to find C. The reason we're not going to use sine B is because there is no sine B, and since we know the exact values of both sine A, 40 degrees, and A, which is 0.5, and sine C, which is under 20 degrees, we can easily find C. So if we do that, it's going to be like this. And again, if we solve this for C, we can easily find that this is around 0.637. So it's that easy. Just plug it into the equation and you can find either a side or an angle that you want, again, using law of sines. Okay, so that was it for non-right triangles. I hope you enjoyed, and I will see you next time for 8.4 that's very messy. Trigonometric equations and inverse functions. Thank you.